Hey, welcome to the course. I'm Ali, your host, a full stack engineer, consultant, and AI engineer based in Melbourne, Australia. A little bit about me: I've been building software for over 10 years, full stack web, mobile, and backend, mainly on AWS infrastructure, across different industries such as retail tech, health tech, fintech, energy. Right now, I'm consulting at Sportsbet through the company I work for, Revity. I have run AI workshops, giving AI presentations at companies like Origin Energy and higher up. This stuff isn't theoretical for me, it's what I do day to day. Oh, and before I forget, I'm also a cat dad, obviously. So this course is about engineering your AI development partner or partners, configuring agents to work the way you work. Now, let's get into the topic here. Large language models. You've probably used one already. ChatGPT, Claude, Gemini, and there are heaps more. Llama, Mistral, Grok, so on and so forth. The landscape is just huge, and it's growing fast. At their core, though, they're models trained on massive amounts of text and data that can generate human-like responses. You give them text, they give you text back. How do they actually do that? Here's a more detailed look into it with a simplified example. This is what happens behind the scenes when you send your message to the LLM of choice. So first, your input goes through what's called a process of tokenization. Your text gets broken down into tokens, individual words or pieces of words, right? So it could be any of them. Then each token gets assigned a number. It's an ID from the model's vocabulary. So, for example, what becomes 2061 becomes 318 and so on. And then next comes the embedding lookup. So each token ID gets looked up in a massive table. It's a matrix that was learned during the training of that model. And when that lookup happens, out comes what's called a vector, which is an array of numbers that represent semantic and meaning. Mathematically, right? So it mathematically represents meaning. And as you can see here, these vectors live in this case, this is a very simple representation of a two-dimensional space, but in reality, it's multidimensional. But it gets the point across. So for example, king and queen are clustered together, cat and dog are near each other, apple, banana are clustered. The model basically figured out these relationships by seeing the patterns in billions of text samples. So then those vectors go through what's called a transformer neural network. It's a mathematical system that learns patterns from training. Now, the math gets deep here, but what basically comes out of it is a probability for the next token. So not the whole answer, but just one token at a time. So for example, the at 55%, Paris at 20%, pick one and append it, and then loop again. So it's token by token until the response is complete. So when you basically see text streaming in from your favorite apps like ChatGPT or Claude Desktop, that's literally one token at a time, decoded back into text and sent to you as it's generated. It's pretty cool, right? Now, can we control these LLMs to some extent? There are three main layers. First, you choose your model: GPT, Claude, Gemini, Llama, so on and so forth. Different models, different strengths. Second, you write a good prompt. Your instructions determine what the model does. Better prompt is always going to be resulting into better outcome. It's simple as that. Always remember that. And third, some variables such as temperature, which control randomness. For example, low temperature, 0.1 to 0.3, predictable, consistent, factual. Great for code. And high temperatures such as 0.7 to 1, it's great for creativity, varied responses, surprising responses, and it's really good for brainstorming. Okay, so now that we know how LLMs work, the token loop, the embeddings, the temperature knob, they're genuinely impressive. But why do we want to talk about agents now? Why do we want to go through this course? And why can't we just use LLMs directly? To answer that though, let's zoom back to where we started. The brilliant mind in isolation. This is actually one of my old messages in ChatGPT that I wanted to show you. And please excuse the typo. I just wanted to show you a real example here. I had this background and foreground listener API done natively for Android. And I just wanted to use the same API for iOS code. So I gave it my code, asked for help, and it gave me back a solid answer. It did work, although worked on paper, but I had to manually grab it and put it in my IDE, fix errors, figure it out how it's going to be shaped on my code base. So there was a lot of manual work, but that's all it could do, right? It could tell me what to write, but it couldn't go into my code base and actually make changes. There was no file system access. It can't run commands. It's a brilliant mind, but it's stuck in a room with no tools. Now, then we move to this era of what I like to call the dawn of agency. So what if we gave that mind hands? That's what happened when we started giving LLMs access to tools. Now, instead of just text in, text out, the LLM can reach out to tools, read files, run commands, make API calls. But how does this actually work under the hood? Let me walk you through the tool calling loop. So step 1, your code sends a message to the LLM. So in this case, you would write the code. It sends the message to the LLM along with definition of available tools that you have. Step 2, the LLM returns a response. Now, because it previously had the list of tools that you had defined to it, depending on the conversations, for example, if you're asking for weather, if you have a tool that has a definition of weather, the LLM predicts to use that tool. And by that, it means that the third step, does the response contain a tool call? In this case, the weather. If yes, then step 4, your code will pause and execute that tool. And then step 5 sends the results back to the LLM. Loop back to step 2. Then it checks no tool calls. Then step 6 returns the final response. Done. And there's the key insight, right? The LLM doesn't execute tools, your code does. The LLM just decides when to call them and what arguments to pass. So we had the brain, we gave it tools and hands, but here is where it gets really interesting. The rise of what I like to call the autonomous agents. What if we don't just give it tools, but also give it roles? What if we have different minds with different responsibilities orchestrating together towards a goal? That's the autonomous agents era. A true agent combines 3 things: the LLM as the reasoning engine, tools for the ability to act, and orchestration that includes roles, memory, coordination that keep it focused. The agent works in a continuous loop. Usually this is how the agents operate. The loop that they go through is your user query. From that goes to think, take action, observe the result, and repeat. Tools like Claude Code that you love and use today have this loop baked run into them. It reads your code, makes changes, runs your tests, observes the results, and it keeps iterating. At the end of the day, it is just a loop. And some agent frameworks actually have prompts like this one you can see here that are baked into them, defining the available tools that they have, default tools you might have heard, and telling the model to reason in a thought, action, observation cycle. Think step by step. Call a tool if needed, observe what happened, and then continue. Now, I would like to point here that when I say autonomous, I do not mean unsupervised. Don't get me wrong, you can get to full autonomy, but you can have guardrails around it, such as alerts or things that will block the agent to do certain things. Okay, so now that we've got agents calling tools in a loop, but there is a problem. How do these agents actually connect to tools and services outside? Agent protocols are the key here. So up to recently, although in the AI world, I don't know how to describe recently, but anyways, you get my point. Up to recently, every app just built its own integrations. For example, Claude Code could have had its own way of connecting to tools. Cursor had a completely different approach, probably Windsurf yet another. These are agentic tools that you're probably already using. If you were a tool author and you wanted your tool to work with all of these, you had to write a separate integration for each of them. There was no standards here. And that's the problem that MCP, the Model Context Protocol, was created to solve. It is a standardized way for any agent app to connect to external tools and services. Now, those external tools and services can be sitting in your local machine or they can be remotely served. Instead of custom integrations everywhere, you had one protocol. Each MCP exposes tools, prompts, and resources. Any agent app that speaks MCP can use these tools. Write once, use everywhere. And there are other agent protocols emerging these days. You have the other famous one, agent to agent from Google. There's also other ones like agent communication, agent network, and so many more. MCP is the big one right now, at least. Now, agents in software development lifecycle. So where do agents actually fit into the way we build software? Think about your typical development workflow. Plan and design, develop, test in CI, code review, release, monitor, and docs and security. Agents are showing up at every single one of these stages, some more than others. So let's look at the different types of agent apps out there. You have your CLI agents, for example, Claude Code, Amazon Q, Gemini CLI. These are terminal-based apps. They're mainly used by developers, but they don't have to be just used by developers. They give the developer that command line experience, which we all love, most of us love. We have IDE extensions like GitHub Copilot. If any of you have used Root Code, I had a huge crush on that for a few months. Plug into editors you already use, like VS Code, JetBrains. And then you have your standard editors like Cursor and Windsurf that are forks of VS Code with agentic functionalities on top. These are full editors with agents built right into the core experience. And tools like Lovable and Bolt AI, those are actually full function applications with agentic AI integrations within them. And then you have your background agents running on servers autonomously, like Copilot Coding Agent, or you can write your own application that wraps the SDKs from Claude or OpenAI that can be used to give your application's AI experience. Now, before we continue, one more thing on the tooling landscape, the gateway layer. What if you want to use different models or route through a unified API? If you don't use a unified API, you would have to maintain different APIs from different providers, Claude, OpenAI, Google, so on and so forth. Though you can use apps like OpenRouter or Requesty, which give you one API and access to so many tools and providers. Requesty is more focused on cost saving and analytics, I believe. You also have tools like Light LLM, which are open source, used for if you want to self-host your models. That's also a gateway. And you have SaaS platforms like True Foundry, a full MLOps platform for deploying and scaling AI applications. So this is not specifically a gateway. Gateway is just a feature of it. It's a full-blown platform. All right, so we've covered a lot. Before we wrap up though, let's set some expectations. So there's obviously pros and cons here, just like anything else. On the pro side, you're basically multiplying yourself, right? Agents run around the clock. You can bake your intelligence into them and they take action on your behalf. Automation is huge here. All those repetitive tasks you've been doing manually, gone. You can identify problems faster, spotting things in logs, catching patterns. Great for documentation, and honestly, you just get a lot more done. Simply put, you ship more. There's a few cons here. Cost. So tokens really add up depending on the model you use. And also you get different ways of paying. One is subscription based. The other one is API call based. So for your every API call, you basically add, and that's how it costs, taken from your credit. That's definitely something to consider. These models can hallucinate. They can sound incredibly confident and be completely wrong. So you need to sanity check everything. Because remember, all they're doing is predicting the next token. These models are non-deterministic, even though we said you can control them with variables like temperature. Same input can still lead to different outputs. These models, although they're getting better, they tend to over-engineer when writing code. They can run out of context window, depending on how much the context window of the model you're using is. Although agents these days have strategies around that to compact, for example, the conversation and then continue your session. And yeah, there's a big one that I have definitely trapped into, which is developer dependency is real. You can start relying on it too much. This is coming from my experience. Some of you might relate to this. And there's also a deeper risk too. Sometimes we stop spending the time and effort on a solution that we used to because it's just handed to us, right? That's something to be aware of. But it's important to now understand that the focus is being more shifted on really thinking about your solutionizing and your input. So then you're completely aware of what you're giving the agent. That is important. Cool. We have come to the end of this section. 4 takeaways. LLMs alone can reason, but can't act. Tools bridge the gap. The agent loop. Think, act, observe. It is the core pattern behind every coding agent. Agents add orchestration and memory on top of LLMs plus tools. And you should always stay in control. Agents are powerful collaborators, not replacements. In the next lesson, we'll get everything set up, clone the course project, install Claude Code, and get going.